Hi everyone. In the given problem statement, we have to solve bitwise AND of a number range. So we are going to given two integers left and right that represent the range left and right. Return the bitwise AND of all the numbers in this range inclusive. So one way could be, right, let us say, and which the intuitive way, right, would be like, let's say I will get the binary of 5, which is going to be 0, 1, 0, 1, then 0, 1, 1, 0, and then 7 would be 0, 1, 1, and 1, 5, 6, and 7. If I do an AND, right, I'm going to get 0 out here, 0, 1, and 0, which value is the 4. 4 is the result. But the problem out here, right, our time complexity would be big O of n, because we have to first take the binary and then keep on adding all the numbers. And if I do it right, I'm going to get a TLE, timeout exception error, right? So it's not going to work. I have to find a better way. So a better way, right? Let me just look into this code, right? What could be a better way of doing it? So let me just take these values and let me have, this is 1, 1, 0, 1, 1, 1, 0, 1. The other way could be, right, I would be just looking into the first row here, right? For 1 it is fine, but let's say I got 0 out here, right? Because I know it's an AND operation, right? So if I found a single 0, the entire column would become 0. Now I am looking into the second one. So here, right, I got this 0, so this is becoming 0, and I'm not going to look into the other one. So only thing that I'm going to compare, right, is this 0 and 1 out here. And these are going to remain constant, so it would be 0, 1, 0, 0. The other way, so it is kind of, let's say, improving the time complexity, but not by that much. So other way could be, right, let me just take an example. 0, 0, 0, 0, 0, 0, 0, 1, then 0, then 0, 0, 1, 0, 0, 0, 1, 1, then 0, 1, 0, 0, and it is going to go through, right, till we reach 1, 1, 1, 1. Okay. Here, right, there could be we are able to see a pattern, right? For the first one, right, after every alternative value, right, the number keeps on changing. So I can say, right, if between my 5 and 7, right, if there if the difference is more than 1, right, so in that case I can say this entire column is going to be 0. Okay. Similarly, on the second one, right, I'm able to see, right, every two alternative elements are changing. Okay. So here, right, if my difference between my left and right, or let's say right minus left, is greater than 2, right, then I can safely assume, right, this will also become 0. If I come here, after every 4 alternative elements, right, its value is changing. So if my it is greater than 4, right, it will become 0. And similarly, right, on the fourth one, after every 8 alternative elements, it will keep on changing, so it will become 0. So based on, right, and if it's 5, right, it will be after every 6 alternative elements. So in that way it is going to work. But to code it up, right, you can do it, and it is pretty straightforward and simple solution only, but it's going to take some time. But there is another way of doing it, and which is a very smart way of implementation. But the problem is that it is not at all intuitive, right? You have to understand how this is going to work. So let me take the example, which is 0, 1 0 1 0 1 1 0 0 1 1 1. These are 5, 6 and 7. So what I can do, right? I can compare my left element and the right element. Okay. So here, right, let me just remove this 6 altogether. My left element and right element, okay. While my left is less than equal to, or let's say is less than R. Okay, so while it is true, right? In that case, what I'm going to do, right? I'm going to have the L and I'm going to right shift it by 1, and similarly I'm going to have R and I'm going to right shift it by 1. So right now, right, 5 and 7 are no longer same. So I'm going to right shift. So if I do right shift, right, this value is going to get removed and this would be my current value which I'm going to look into. So 0 1 0 and 0 1 1. It has been right shifted, so value would be like 0 0. Now if I compare it up, right, it is still not the same. So I'm going to again do a right shift out here. Okay. And here I'm going to also have, let's say, a shift value which is going to be 0. Whenever I'm doing a shift, right, so I'm going to increase shift plus equal to 1. So I'm again doing a right shift, so shift value would be 2. So now, right, the value would be looking like 0 0 1 0 0 1, and here would be 2 0. Now if I compare both of them, the values, right, so both of them are right now same, so no longer need to do any right shift, so it is looking fine. But this value is 1, right? So I also need to make a left shift of the number of times it shifted to the right. Same number of times I have to shift it to the right, the value that I got. So this would be my value. So if I do 0 0 0 1 and I'm shifting it to the left by, because number of shift is 2, right? So it would be something like 0 0 1 0. Okay, after shifting. No, I'm doing it shifting twice, right? So it would be 0 1 0 0. And here other zeros will come on. Okay. And if I take the integer or decimal value of it, right, because I know it would be 0 into 2 to the power 0 plus 0 into 2 to the power 1 plus it would be 1 into 2 to the power 2. So the value we are going to get, right, it's 4. And here, right, we are able to see the 4 is the output. So the basic idea out here, right, we are just going to do, first we're going to do right shift till L and R are becoming the same. And once that is done, right, whatever value that is left of L, right, we are going to do a left shift so that our values is going to remain same. So the idea is, right, here, right, this was the output, right? And if I remove both of the values, so the value remaining is just 1 0. So I'm going to do a left shift because you have removed two values, right, and two values will become 0. So this is the output and this is going to be the value, the 4 would be the result. So in that way, right, we have to going to get the result. Now let me jump to the Python solution, and the solution is very very easy. Only thing is that you have to understand how bitwise and bit manipulation work. So that can be a little bit complicated to understand, but I think if you solve enough problems, I think these things are going to get clearer. Let me jump to the Python solution. So the first thing we are going to do, right, we are going to assign a variable shift to count the number of times we are shifting. So while left is less than right. So I'm going to do a right shift on left. So left equal to left right shift by 1. And similarly, you're going to do for right, you're going to do a right shift by 1 for the right value. And because you have done a shift one time, so you're going to increment shift by shift plus 1. Once that is done, right, I'm going to return, and I can return, right, because now both left and right value would become same after doing the shift operation. So it can be left and right, it doesn't matter. For the sake of simplicity, I'm just doing left, and we're going to do left shift by number of times you have shifted. So it would be left shift by shift. Let me run it. It's just few lines of code. The problem or the code is very simple, but in order to come up with the solution, right, it is a lot complicated. So you need to understand how entire shifting and how bit manipulation and all those things work. It is giving a runtime of 29. I think if I run it back again, it is going to give me a way better time complexity, because I think here, right, because you're doing just bit manipulation, right? So let's say you have 32 bits, right? So in that case, the time complexity would be big of 32, because you're just shifting it on that number of times. I think there are people who have better solution. I don't know. Let me resubmit it and see how it works. As you could see, it increased significantly to 62.43. I think it can be further optimized. I don't know. I am not sure how it can be optimized. So if you have a better solution, right, which is going to give me a more optimized solution, do feel free to let me know in the comments. That's all for this video. See you in the next one.